Now the next topic is power of element in groups. Let's see this topic. Power of an element, power of a particular element. Before I ask you this question, before we study this topic, we should solve this question. Tell me, in a group word, can we say that this will happen? This is your associative property. Can I say in a group word this will happen? In a group word, can I say this will happen? The answer is no. In a group word, this need not happen. Can we say that this will happen? No. Can we say that this will happen? No. We cannot say this will happen. Okay. So in a group word, we cannot say this will happen. Can I say this will happen? A star A equal to this. Can I say in a group word this will happen? See, this will not happen. But what about this? Can I say this will happen in a group word? Think about it. In a group word, we know this is your associative property. This will not happen. What about this? A for same elements, can I say for same elements? The answer is still no. Can anyone give me counter example? So you can actually take this counter example. You can take. Consider this. Consider this power set of AB, power set of 1 to 3, power set of 1 to 3, and set difference. Set difference. Power set of 1 to 3 and set difference. Tell me, is this groupoid or semi-group or what? This is groupoid. This is groupoid, but this is not associative, right? This is not associative. Because this is set difference. This is your set difference, and set difference is not associative. This set difference is not associative. So power set of 1 to 3, how many elements we have in the base set? In the base set, how many elements we have? Total 8 elements we have. Your base set is power set. So in the base set, you have 8 elements. Base set has how many elements? So the cardinality of the base set is 8. In the base set, you have 8 elements. Your base set is this. Your base set is not this. At least 1,000 times I have told you this. Take care of the base set. At least do this. So base set cardinality is 8. This is your base set. Okay. Now, so this is a group word. Now, can anyone give me an example where this will not happen? This will not happen. Now you can notice that if you take, for example, this if you take, then you can notice that this will not happen. If you notice this is not equal to, if you notice this is not equal to this, agree? This will be 5 and this will be 1. So these two are not same. You can notice in this. Okay, so understand this. P1, 2, 3 and the operation is set difference. Now I'll take element, this element you take. Take this element. Now what will be A star A? Can I say this is equal to A star A? Remember your star is set difference. Your star is set difference. So here I can basically I can say that the question is asking, this is what the question is asking. Can I say this is same as, can I say this is same as this? And you can clearly see this will be 5 and this is not equal to this. So you can clearly see that in the group word, can we say that this will happen? No. But what about semi-group? In a semi-group, can I say this will happen? In a semi-group. In a semi-group, yes, this will happen. Because of associative property. The reason is associative property. The reason is very simple. The reason is associative property. And one thing you should understand, in the last lecture we have seen that when you have associative property, you can remove the parenthesis, right? In case of associative property, you can remove the parenthesis. This, okay, no need to put parenthesis. No need to put parenthesis. Agree? Yes or no? Agree. So if you have associative property, then there is no need to put parenthesis. You don't have to put parenthesis. So finally, I can say that this A star A star A, you can directly write it A star A star A. You can directly write like this. And that is same as A star A star A. So directly you can write like this because it will satisfy associative property. This is semi-group. Semi-group means associative property. And when you have associative property, then there is no need to put parenthesis. This parenthesis, there is no need. You can remove this parenthesis. Okay, now let's see some concept. Power of element. How to define power of element in a group? So this is very simple concept. If you have a group G comma star, let's assume this is a group. Let's assume this is a group. Then how will you define power of element? Now for all A, what will happen? For all A, this is how you can define what is A power. For example, let's see what is A power n, or what is A power, what is, for example, let's see what is A power 3. Can anyone tell me what is A power 3? That means A star A star A. That simply means A star A star A. Remember, this star can be any operation. This star can be any group operation. This can be any group operation. This does not mean multiplication. Don't think it is multiplication. This is any group operation. This is just a group operation. So A cube means A star A star A. What is A power 1? That will be A. What is A power 2? That will be AA. I can directly write it AA. Okay. So because it simply means A star, I am doing the star operation. So I can just directly write it AAA. Okay. Anyway, so this simply means A star A. Now think about it and tell me what this will mean. A power minus 3. What do you think this means? What do you think how this is defined? How do we define this? What is the definition of this? So let me tell you. The definition is like this. The definition is like this. This is the definition. So means this inverse element you multiply, you do 3 times. This inverse element you put star. Remember, this is your group operation. So you have to put, this is not multiplication. Don't think it is multiplication. It is group operation. Okay, so this is how you can define. And what do you think how we define this? A power 0. What is the definition of A power 0? A power 0 is always E. A power 0 is always identity element. This is always identity element. Okay, so this is the definition basically. Let me tell you, this is the definition. So in any group, for any element, this is the definition of power. A power 0 we define as E. Always in every group, for every element, A power 0 we define as E. Okay, so this is the definition. Remember this point. This is the definition. This is the definition. Okay, so there you don't need to prove it. This is how we define. Okay, so A power 0 we define as E. A power n we define like this, and A power minus n we define as A inverse power n. So this is the idea. Let's take some example and let's try to see. And let me tell you one more thing. This power is defined in any semi group. In any semi group, you can define this power. Okay, so like, because in a semi group, you have this associative property. So whenever you have this associative property, you can define this power. Anyway, let's take this example. Tell me about this one. I am giving you a group 1 comma minus 1. Okay, let me give you this group 1 comma 2 multiplication modulo 3. 1 comma 2 multiplication modulo 3. Is this a group? Is this a group? You already know this is a group, right? You already know, because these are the prime. These are the co-prime of co-prime less than 3. These are co-prime less than 3. Okay, next. So this is a group. Now tell me, what will be 1 power 5? What that will be? What is the identity element here? What is the identity element? Identity element is 1. So what will be 1 power 5? Think about it and tell me. 1 power 5. 1 power 5 will be 1 multiplied by 1 multiplied by 1 multiplied by 1 multiplied by 1 mod 3. Okay, so that will be simply 1. You can find what is 1 power 2. 1 power 2 will be 1. Now you can find 1 power 3. 1 power 3 means 1 power 2 into 1 power 1. So okay, 1 power 2 you can find, that is 1. Because what is 1 power 2? 1 power 2 means this is 1 power 2. So this is your 1 power 2. Okay, so that will be 1. You can notice this is 1 power 2. So 1 power 3, how to find? 1 power 2 dot 1 power 1. 1 power 2 is 1 dot 1. Now what is 1 dot 1? That you already know, that is 1. 1 dot 1, that is already know, that you already know that this is a 1. So this is the idea. Okay, now tell me, what is 2 power 2? What is 2 power 2? 2 power 2 means 2, this operation, so that will be 4 mod 3. That will be 4 mod 3, and that will be 1. So 2 power 2 is equal to 1. Like this you can find power. Let's understand this question. 0, 1, 2, addition modulo 3. Is this a group? Is this a group? Yes, this is addition modulo 3, because this is what? This is your Z3. Okay, now tell me, what is 2 power? What is 2 power 2? What is that? 2 power 2 means this is your 2 power 2. Remember, apply the operation, apply the group operation. Now this is your group operation. Here this is the group operation, so take care about the group operation. So this is your group operation. So finally I can say this will be here, it will be 4 mod 3, and that will be 1. So 2 power 2 is equal to 1 here. What is 1 power 2? What is 1 power 2? That will be 2. 1 power 2, that will be 2. Okay, so this is the idea. Don't say 1 power 2 is 1. That will happen in number theory. 1 power 2 equal to 1, this happens in number theory. So don't do these things here. We are not studying number theory, we are studying group theory. In this group theory, this group operation is everything. This group operation you have to apply. So don't make this mistake that 1 square is equal to this 1 square. No, don't do this mistake. This will happen in number theory. Okay, another question. For set of whole numbers, comma addition. Is this a group? Set of whole numbers, comma addition. Is this a group? Is this a group? This is not a group. This is actually monoid. This is monoid. This is not a group. Okay. But you can define power. Remember, this power concept you can define for any, this power you can define for any semi group. Power of element. Power of element. This power of element is defined for any subgroup. For any semi group. Because semi groups are associative. Okay, so for any associative, for any semi group, we can define this power of element. Anyway, so let's see this. So tell me, what will be 2 power 3? What that will be? 2 power 3. 2 power 3 means set operation. Look at set operation. Your set operation is plus. So because your set operation is plus, so it will be 6. What will be 2 power n? In this, what will be 2 power n? Where n is, let's assume where n is greater than or equal to 1. If n is greater than or equal to 1, then what is 2 power n? Then that is 2n. What is 2 power 0? That will be the identity element. That will be the identity element. Inverse power you cannot define here. You cannot define this 2 power inverse. This is not defined here because this is not a group. Why not defined? Because this is not a group. So because it is not a group, you cannot define this inverse power. Sorry, this negative power you cannot define. This is not defined. 2 power 0 is always identity element. 2 power 0, this is identity element. What is the identity element? What is the identity element here? The identity element is 0. So 2 power 0 is 0 here. Is it clear? Because remember a power 0 is always identity element. Okay. Now these properties they hold because of associative property. These properties they hold because of associative property. All these properties they hold because of associative property. Because of associativity. So because of associativity, comma inverse. Because of these two, these properties will hold. These are same properties which you have in number theory. For example, if I give you, tell me a power 3, a power 2. This is same as a power 5. Why? Because of associative property. Because of associative property, this thing is same as this. Okay, so you can notice these properties they satisfy because of associative comma inverse property. So I can say that a power m, a power n, that is same as a power m plus n. Similarly, a power m, a power minus n, that is same as a power m minus n. All these properties they hold. A power m power n, that is same as a power mn. Because of associative, these, for example, if I ask you what is a power 2 power 3, then what it means? It means a power 2, a power 2, a power 2. Now what it means? It means a, a. And because it is associative, so you can remove the parenthesis. So this is same as this, and this is same as a power 6. Is this clear? These properties that you have in number theory, these properties you also have in number theory. In your normal mathematics also you have these properties, and these properties we have here also because of associative property. Just think about it. Yes or no? For example, if I ask you what is a power 2, a power minus 2, that will be simply a power 0, and that will be simply identity element. If we don't have identity element, then a power 0 will not be defined. For example, here we don't have, see, in this example we don't have inverse, so negative power is not defined. Same thing you can do here. For example, just take this question, set of natural numbers comma addition. This is not a monoid, this is semi group. You can notice this is a semi group. So if I ask you here what is 1 power 2, then that will be 1, that will be 2. But if I ask you what is 2 power 0, that is not defined. This is not defined. Why this is not defined? Because we don't have identity element. This is not defined because there is no identity element. Basically, this power 0 will always be, the power 0 will always be identity element. This is how we define power 0. Again, I am telling you, this is the definition. This is the definition. Okay, so this is how we define. This is how we define the concept. So you can notice, because we don't have identity element, so we cannot define power 0. We cannot define power this because there is no inverse. Take this group. 1 comma minus 1 comma iota comma minus iota multiplication. So here you tell me what is iota power minus 3. What is that? So what is iota power minus 3? That simply means inverse of iota power 3. What is inverse of iota? Inverse of iota is minus iota. If you notice, inverse of iota, that is equal to minus iota. Because just think about it. What is inverse of iota? What should I put here such that I get 1? What should I put here? What should I put here? I should put minus iota. I should put. Okay, so iota inverse is minus iota. So finally, iota inverse, that is minus iota power 3. That will be minus iota cube. And that will be what? Iota cube is what? that is minus iota. So finally it will be iota. So the final thing will be iota. Yes or no? So iota power minus 3 is iota. This iota power minus 3, that will be simply iota. So like this you can find. For example, if I ask you what is minus iota power minus 5, what that will be? Now you can use this result. This result you can use minus iota power minus 5. You can call it minus of iota power minus 5. You can write it, okay, because you can write it minus of iota power minus of iota power minus 3, iota power minus 2. Iota power minus 3 is iota. Iota power minus 3 is iota. And what is iota power minus 2? You have to find iota power minus 2. So what will be the iota power minus 2? That will be minus iota power 2, and that will be minus 1. Okay, that will be minus 1. So this will be minus 1. So finally again we will get iota. Iota power minus 5, this will be iota. This will be iota. So like this you can find. What is minus iota power minus 4? Let's find it out. Let's find it out. What this means. First of all, minus iota power minus 4. First of all, what you can do? This you can write as minus iota inverse. Minus iota inverse power 4. What is minus iota inverse? What is minus iota inverse? Can anyone tell me what is minus iota inverse? That is iota. Because iota inverse is minus iota. So minus iota inverse is iota. Is this clear? Is this clear? Minus iota inverse is iota. We have already seen this. This structure we have already done. Complete analysis of this structure we have done. So you can notice that. So minus iota inverse, that is this minus iota inverse, this is iota. This whole thing is iota. Now what is iota power 4? That is iota multiplied by iota multiplied by iota minus multiplied by iota, because this is the group operation. This is the group operation. So finally what you will get? You will get 1. If I ask you what is a power minus 5, then this means a inverse power 5. This means a inverse power 5. Okay, is this clear? So if I ask you what is minus iota power minus 4, that means minus iota inverse power 4. That means minus iota inverse power 4. And what is minus iota inverse? That is iota. So iota power 4, and its iota power 4 is this, because group operation is multiplication. So finally you will get 1.